Hi, and welcome to this On Maths prediction for the AQA Foundation Tier Paper 3 GCSE Maths 2018. Enjoy! Hiya, okay, so I hope Paper 1 and 2 went alright. We've now removed the Paper 1 and 2 topics to get you a Paper 3 prediction. Like I've said in the previous videos, please use this in amongst all your other revision. There's plenty of topic busters on the site which cover all the GCSE topics, not just the ones in this prediction. The downside of a prediction is it can only be the amount of marks in the paper. There are plenty of topics that could come up that still haven't, and also the exam boards are notorious in repeating some of the previous topics. So use this as a starting point, or use this as a bit of a revision break, a revision check, but please also do the standard revision as you would normally, and see this just as a revision tool. Like always, you can do this online at onmaths.com. Also, if the servers get busy, which they normally do probably the day before the exam, then please use our backup site, which will be in the description. I hope you enjoy this video, and if you like it, please click like. If you really like it and want to see more from us, click subscribe. Thank you very much. When you're rounding numbers to significant figures, first of all write out the number. And with significant figures, you want to draw a line after the second number. So the 6 is the first number, the 3 is the second number. Now, unlike decimal places, you're not looking at counting from the decimal point. You're counting from the start of the number, and we'll have a look at an exception to that on question B. Then we look at this number. Now, this number and the 2 are doomed. They're gone. But they're not quite done yet. That blue one has to make a decision. If that number is a 5 or more, that 3 will go up by 1. If it's less than 5, that 3 will stay the same. Now, because it's less than 5, that 3 will stay the same. But have a think about it. If 6,312 people visited or were at a football match, and someone said, "Oh, can you tell me roughly how many that was?" If you said 63, that doesn't make any kind of sense. So the mistake that I've made, and the mistake most people make with this question, is they forget that the 1 and the 2 don't disappear. They turn to 0. So the answer is 6,300. Now on question B, this is an exception that we've got to remember with significant figures. You don't start counting until you hit a number that's not a 0. So the first number is 5 and the second one is 2. So the line will go here. Then let's have a look at our decider number, where it's 1 again, so it's less than 5. So we're going to have 0.052. Now, I could put 0, 0 in here, but this time the numbers aren't actually affecting anything. Was before, the 2 zeros there were holding that 6 to 6,000 and the 3 to 300, so they were really important. The zeros here aren't actually changing the number at all, so we don't need to have them. So the answer is 0.052. Okay, so this question is about coordinates, and the biggest mistakes with coordinates is getting them the wrong way around. So point A, which is this one here, it's either going to be 2, 1 or 1, 2. And the way of remembering it is you always go across first and then up. You go along the corridor, up the stairs. Okay, so you always read off the x-axis and then the y-axis. So the coordinate is 2 because we go 2 to the right from the middle, and 1 because we go 1 up. Now coordinate B is the same, so we're going along the corridor to -2 and then up 3. So along 2, or we'll go to the left 2 and up 3. Okay, it's asked us for which coordinate is at a point -2, -3. So we're going across to -2 again, but this time we're going -3, which means down 3. So it's going to be coordinate C, because C is at -2, -3. Okay, so we're asked which 2 points on the line y equals minus 2. So we've got to understand what y equals minus 2 is first. Y equals minus 2 is a line where y is always minus 2. Well, we know y is minus 2 here, but also y is minus 2 here, and actually anywhere across this line. And we call that line y equals minus 2 because y is always minus 2 along it. If you have a y equals line, it'll always go from left to right. If you have an x equals line, it'll always go from top to bottom. So the two coordinates on that line are D and E. So the 2 points on the line are D and E. To do this question, the best thing to do is just put lines down the page and then we can compare these numbers easier. So I'm just going to ignore the pound sign, so let's put in numbers. So 1, 2, 9, 5, 1, 3, 0, 4, 1, 2, 9, 9, 9, 4, 2, and 9, 3, 6. And to get the smallest, because we're starting with the smallest, we look at this column. Well, these two here are the ones that have a 0 there effectively, so we're looking at these two. And then I look at this column, well they're both 9s, then I look at this column, so it's 936. So it's 936 pounds, and then it's 942 pounds. Okay, so we look back at the first column again, and we notice that all three of them are 1s. So we're looking at these columns because we've already dealt with those. So we look at the next column. Well, there's 2 of them with a 2 there, so we're no longer looking at that column. In fact, we can put that in as the biggest now, because that's the only one that has a 3 there. Okay, so we look at the next column. Yeah, they're both 9s, and we look at the last column. Well, we've got 1,295 is the smallest, because 5 is smaller than 9, and then we've got 1,299 is the next biggest. Okay, so this is a football team's 30 games and how many goals they scored in them. And it asks us for the total number of goals the team scored in the season. So in 2 of the matches, they scored 0 goals. So the first box, they haven't got any goals at all. 3 of the matches, they scored 1 goal. So they've scored 3 goals 3 goals in those 3 matches. In 8 of the matches, they scored 2 goals. So that's 16 in total. And all I'm doing here is timesing these two together. 12 matches with 3 goals, so that's going to be 36. And in 5 matches there were 4 goals, so that's 20 goals in total. Now in total, we're going to add those together, so 3 plus 16 plus 36 plus 20, which is 75. So they've scored 75 goals in total. Now the next question asks us for the mean number. Now the mean is all the numbers added up, which actually we've already done, 75, divided by the total amount of numbers. Now we could add up this column here, but actually it tells us in the question that there are 30 games, so I know they'll add up to 30. So we're doing 75 divided by 30, and it says it wants it to 2 decimal places, but actually this one will give me the answer of 2.5. So I could leave it as 2.50 if it needs it to 2 decimal places. So for the first question, when you're adding letters together, the answer will be a number and then that letter. So we've got 1, 2, 3, 4, 5. So it's going to be 5b. The most common wrong answer is b to the power of 5. Now that's wrong because that only happens when you times them together, when you multiply them together. So it's going to be 5b for the first one. Next one is 10 lots of f, and we're taking away 3 lots of the f. Well, how many f have we got left over? Well, 10 lots of it and take away 3 lots of it means we've got 7 lots of it left. When you're simplifying one like this, in algebra we just don't use the time sign, so this is quite a nice easy question, 10ab. Now the last one is like terms. So we've got 5x here and we're adding 5x, and we've got a 3y here and we're taking away a y. So when you add the 5x to the 5x, you get 10x. And when you've got 3y and you're taking away y, which is short for 1y, so we've got 3 y's, taking away 1y, we're left with 2y. Now you can't simplify that any further because they are not like terms. You can times them, but you can't add or subtract them. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up, but I'm going to do this in pence. So I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark, but if you actually wrote the gradient as well, then you definitely get the mark, and sometimes it will ask you for the gradient and then ask you to interpret it. Okay, so with this question there are quite a few steps we've got to go through. So it gives us some information about the parallelogram, that the area is 3 times the area of the triangle. So it looks like the place to start is the area of the triangle. So we're going to start off with the area of the triangle, and it's really important for these types of questions to be really clear to the examiner what you're trying to work out. So the area is half times the base times the height. So it's half times 8. I was going to write 6 there, but let's keep it in the same order. Let's tidy up that 8 a little bit. Okay, so half of 8 is 4, times 6 is 24, or we could do 8 times 6, which is 48, and then half of that. Either way, you get 24. Okay, so we know that the area of this is 24 centimeters squared. And we know that the parallelogram is 3 times the area of the triangle. So the area of parallelogram equals 24, which is the area of the triangle, times by 3. Now I know 25 times 3 is 75, so I can take away 3 from that, it's 72. So equals 72 centimeters squared. Now, I know that the height of it is 12, and I know to work out the area of a parallelogram, it is just base times height. And I know that the height is 12, and I know the area of it 72. So I just need to solve this. Quite an easy one to solve, because I'm just going to divide by 12. So the base is going to be 72 divided by 12, which is 6. So it's going to be 6 centimeters. Now we can work that out and just work backwards. So if this x here is 6, 6 times 12 is 72. Then I could do 72 divided by 3, which is 24. And 24 is the area of the triangle. So you kind of know you've got the right answer because you can work backwards with it. So we're told 1 kilogram of cheese costs £7.70. How much would 600 grams cost? Well, first of all, I'm going to have weight, mass, and price. And I'm just going to sort of split them down the middle. So the weight, well, 1 kilogram is not going to help us because this one's in grams, so I'm going to convert that to grams. So it's 1,000 grams, and I'm going to convert this into pence, so 770 pence. Okay, so I need to get to 600 grams. And so first of all, if I've got a calculator, I can do this a lot easier, but without a calculator, let's try. Well, I can first of all divide this by 10 to get it so that it's 100. So that's 100 grams, and that would be 77. And then what I can do is I can times these by 6 to get 600. Okay, so if you've got a calculator, you can just type it in, but let's assume that you don't for this question. So we've got 77 times 6. 6 times 7 is 42. Add a 0. 6 times 7 is 42. Add them together. Probably don't need to do this, but anyway, I'll do it anyway. 264. So it's 462 pence. But in pounds it would be £4.62. Last thing, just check it makes sense. Well, we've got just over half, so therefore the price is just over half. So it looks good to me. Question A seems like a really complicated question, but it really isn't. If you think about what you know about a rectangle, you know that opposite sides of a rectangle are equal. So if you just write down x plus 1 is the same as 12 and then solve it. So what we're going to do is we're going to take away 1 both sides. Then x equals 11. So we know that x is 11. Let's check that out. It says here x minus 1. Well, what is 11 take away 1? Well, it's 10. And that is the same as that. So we know that x equals 11. And that's it. Question B. Have a think about what you know. You know that all angles in a triangle add up to 180. So we know that if we add y, 2y, and 3y together, it's going to equal 180 degrees. So again, let's just get our lines down so that we can solve it. So 1y plus 2y plus 3y, well, that gives us 6y in total. And then what we need to do is get rid of that times 6 there by dividing 6 both sides. So y equals 180 divided by 6. Well, I know 18 divided by 6 is 3, so I know that's going to be 30. First thing we need to realise with this question is which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps. And the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2. I need to go 2 left. So 2 left. And let's have a think. How much up do we have to go? So 1 jump, 2, 3, 4. So 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up. So it's just a 4 there. Now, here's a problem. This is how far right it's gone, but it's gone to left. Well, we just simply put -2 right. Now, be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. For these types of questions, always make sure that you show your working, show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103. Therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, put a little time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48. And then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative, because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. Two minuses times together is a plus. 3 times 5 is 15. Then we look for like terms. So we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. The place I always start with questions like this is just drawing a diagram so that I can get my head around what the questions ask me. So we've got 3 place names, Chelton, Bocco and Devley, and I'm just going to label them as C, B, and then we stop at Devley on the way, so I'm going to call that D. And normally place names and people will have different first letter, so you can just name them with their first letter. So distance from Chelton to Devley is 26 miles, so we know that's 26 miles. And the speed was 52 miles per hour. Okay, and the time he left Chelton was 9 o'clock. Okay. And so we're looking for the speed to get there at 9:45. Okay, so it's clear in this question that we're looking at the relationship between speed, distance and time, and most people use the triangle for this, which we've got speed, distance at the top and time at the bottom. And what you do with this triangle is just cover up the one you're looking for, and it tells you how to work it out. So if you cover up speed, it's distance over time. If you cover up time, it's distance over speed. And if you cover up distance, it's speed times time. So here we're given a distance, we're given a speed, and we're looking for the time. So the triangle tells me to do distance over speed, so 26 over 52. Now I can divide 1 by 26, that's going to be a half. So it's half an hour. So we know that David's going to get to Devley at 9:30. So that means that he's got to, well, let's have a look. I've missed out a piece of information there, that it's 17 miles. So the distance is 17 miles. And we now know that the time is going to have to be a quarter of an hour. So we're looking for the speed, well, that's distance, which is 17, over time, which is a quarter. Now when you divide by a quarter, it's the same as timesing by 4. So if you've on the num calculator, you can do 17 times 4, and what you can do is, instead of 17, it's 10 and 7, 4, and that would be 40, that would be 28, and so you add them, so it'd be 68. Obviously if it's on the calculator, you can just type into the calculator. So he's going to have to travel at 68 miles per hour to get there in time. When numbers are quite small, it's quite easy just to do trial and error to find the highest common factor and the lowest common multiple. But when the numbers are larger, then the way we do it is with product of prime factors. Now this could come up on a paper which has previously had product of prime factors, and this is distinct enough maybe to come up in its own right. So just because product of prime factors have already appeared, this question has already done that bit for you. So how are we going to do it with these large numbers? And 3,675 and 84 are pretty large numbers. Well, the way we do this is with a Venn diagram. Now I'm going to use the space down here to do this, and what I'm going to do is, because I find it easier, I'm just going to write it not in index form. Then when I do my Venn diagram, I can just cross them out when I've done them. So 2 times 2 times 3 times 7. Okay, so let's construct myself a Venn diagram. Okay, now I'm not very good at drawing circles, but I'm going to try my best here. I'm going to try and make the circles as big as possible. So we've got 3,675. I'm just labelling which circle is which, and this is 84. And to do the Venn diagram, we're just going to go through the numbers and write out which ones overlap and which ones don't. So if I have a look at the 84 first, we've got a 2 there. Well, 2 doesn't go into 3,675, so that 2 is going to be on its own there, and this 2 here is going to be on its own. Okay, I think that's it. So the next one, now this 3 appears in both lists, so this 3 goes in the middle. The 5 here only appears in 3,675, and same with this one. And then we've got 1 7 that appears in both lists, but we've got another 7 in the 3,675 list. So that's my completed Venn diagram. Now, to answer question A, to find the highest common factor, all you need to do is multiply the overlapping ones together. So the highest common factor is 21, and that's it. There we are, it's that easy. Now, to find the lowest common multiple, which is question B, what you need to do is times all of them together, every single one. Now you might wonder, well hang on, surely that's just going to give us 3,675 times 84, so why couldn't I just do that? Well, the overlapping ones we're only going to write once, so the 3 and the 7 in the middle, we're only writing them once. So we would, if we did 3,675 times 84, we would be timesing by 3 and then timesing by 7 again. So we've already done the middle bit, so we've already done the 21 in the middle, and I need to do the ones around the side. So we've got 5 times 7 times 2 times 2. Now on the non-calculator paper, it might be a bit more generous with the numbers. This one is probably going to be more on the calculator paper, although there are ways that you can do this. For instance, I could pair the 5s and the 2s up, and that would make 10. The 5 and the 2 there would make another 10, so we've got 100. So all we need to do is 21 times 7 and then put 2 zeros on the end of it. 21 times 7 is 147, so put 2 zeros at the end of it. If it's on the calculator paper, you just literally use your calculator to times them out. And so that's 14,700. Well, the chances of us finding that with trial and error are close to impossible, so you can see why this method is so good. So when you have a right angled triangle and you're given 2 of the lengths, and you're asked to find a third length, which I'm going to call x, then it's going to be Pythagoras. Be careful, because if there's an angle involved, either you're asked to find an angle or you're just given an angle on the side, then you'll be using trigonometry. So when we use Pythagoras, there are 2 methods that I know of to work it out. There's the Algebraic Method, which is a squared plus b squared equals c squared, and that's absolutely fine to use. I'm not going to use that method, because if you're happy using that method, go on, use it, not a problem. The only thing to remember about that method is that c must be the hypotenuse. Okay, now I'm going to do a method that doesn't involve algebra at all for people who are not very happy with the a squared plus b squared equals c squared method. So my method comes with 3 steps. Step 1 is just square every number that you have and put the biggest one first. Okay, so I'm going to do 7.1 squared and I'm going to do 4.6 squared. So on my calculator, 7.1 squared, and that equals 50.41, and 4.6 squared equals 21.16. So step 1's done, I've squared them all. Step 2 is the only choice you have to make. You either have to add or subtract. Okay, now this is where we talk about the hypotenuse. The hypotenuse is the length that's opposite the right angle. So go to the right angle, go across from it, and that is the hypotenuse. So 7.1 is the hypotenuse. Now what's special about the hypotenuse and why it has a special name is it must be the longest side. So in step 2, have a think, well, if we add them, we'll get a bigger number. Well, the hypotenuse must be the biggest side. So when you're finding another side, not the hypotenuse, you will subtract. But if I was finding the hypotenuse, so I wanted a bigger number than the other two, then I would add. So I'm going to do 50.41 minus 21.16, and that's why in step 1 we did the biggest one first, because otherwise you'll get a negative number. So 50.41 take away 21.16, and that equals 29.25. Okay, and step 3 is a nice easy step. It's just root it. So with this one, I'm just going to press square root answer, and then I have, so I'm going to write that down, square root 29.25, and so that equals 5.4083, blah blah blah. It says it wants its 2 decimal places, so I'm going to write 5.41 because that 8 moves that 0 up by 1. Now, last step is just check it makes sense. Well, this being 5.41 means that the 7.1 is still the longest side, so we know we've probably got it right. Okay, so this question looks a little bit complicated, in fact very complicated, but whenever you have this type of question where you've got different categories of people or items, the best method and the clearest method is to draw a quick two-way table, which I'm going to do now. So I'm going to draw a quick two-way table, and the options for the people are either they are male or they are female. We'll add a total column or a total row, and they either do maths, English, science, and again I'll add a total as well. Okay, so I can add some lines in as well. In fact, let's do a different colour to make it a bit clearer. Okay, the absolute total is 123. Okay, and we just go through it and fill in the bits we do know. So 57 of the students are female, so 57 females. 15 of the 36 students who went to English were male, so there's 36 students who went to English, and 15 of them were male. 33 students went to science, and 29 males went to maths. So 29 males went to maths. Okay, what we asked for, so we're looking for the females who went to science. So if I highlight that, so females who went to science. So we're looking for this one here. Okay, so what you can do with this question is just try and fill out the bits that you can, right? So I'm going to start off with this top one here. Okay, and there's different ways of doing this. Now, if there's 123 students in total and 57 of them are female, then 66 of them will be male. Okay, because these two here have to add up to 123. Then if there's 66 males in total and 29 of them went to maths and 15 of them went to English, then that leaves 22 who went to science. And if there's 22 males who went to science and there's 33 people in total who went to science, then there's going to be 11 females who went to science. Now there's different ways of doing this question, and actually you didn't need to do a two-way table for this question. It's just a lot easier to check your answer, and I find it a lot quicker. So if you have this type of question, a two-way table is probably the way to go. Okay, so in this question we're given recipes for 12 biscuits, and that's going to be important. But we're also told that Fred wants to make 18 biscuits, complete the new list of ingredients, like the amounts of the ingredients. So I've got to somehow get from 12 to 18 by just timesing or dividing. So I can't really think of a way to get from 12 to 18 easily without a calculator directly. So what I'm going to do is I'm going to go to 6 first. I'm going to divide the 12 by 2, so halve it, and then I'm going to times the 6 by 3. And that will get me to 18. Now, some of you might think, well, why can't we just add 6? Proportion doesn't work with adding or subtracting. You've got to times or divide to keep everything into proportion. So what I'm going to do with each of these ingredients is I'm going to halve them to find out what the amounts for 6 biscuits are. And then I'm going to times them by 3 to find out the amounts for 18. So half the 84 would be 42. Half the 60 would be 30, half the 24 would be 12, half the 2 would be 1. And now, because we've got 12 biscuits here, and we've halved them to make 6, a different way of doing this is just adding them together. 12 plus 6 is 18. So instead of timesing the 42 by 3, I could just add it to the 84. So I could just do 84 plus 42, which would be 126. Again, 60 plus the 30, which is 90, 24 plus the 12, which is 36, and 2 plus the 1, which is 3. So the answers are 126, 90, 36, and 3. Okay, second part of the question says that we've got enough of every other ingredient, but only 1 kilogram of flour. Now, first thing to note here is that 1 kilogram is 1,000 grams. So that's really important to know for this. And we need 84 grams of, and I'm going to do my working up here, but normally in your exam, make sure you do it underneath the question. So we know that 84 grams gives us enough for 12 biscuits. So I want to work out how much 1 biscuit would be. So I'm going to divide both of those by 12 so that I can work out exactly how many biscuits I can make. So it's 84 and then divide it by 12, which you can do any method you want. The answer will be 7 grams. So 1 biscuit's going to be 7 grams. And now we've got 1,000 grams. So what we want to do now is we want to work out how many 7s there are in 1,000. So we need to do 1,000 divided by 7. And this isn't the only way of doing this. Now, to do 1,000 divided by 7, what you could do is just keep going through the 7 times table. You might start off with 7 times 100, which is 700, and keep going there. Or you might use the bus stop method. And there's loads of different ways of doing this question. So I'm going to use the bus stop method. 7s into 1 don't go, so that 1 carries on. 7s into 10 go once, and then we carry the 3. 7s into 30, well, 5 times 7 is 35, and 4 times 7 is 28, so it's going to be 4 with 2 carried on. 7s into 20, well, 7 times 3 is 21, 7 times 2 is 14, so it's going to be 2. Now, we could carry on and push on the 6 remaining, but actually it just shows us that we've got 142 whole biscuits and then some biscuits left over at the end. So we're only interested in how many biscuits he can actually make, which would be 142, but he might have like some flour left over, but it wouldn't make a biscuit. So the answer is 142. In this question we're asked to compare two banks, and normally when I'm asked to compare something, I just put a line down the middle of the working out, and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all, I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money. So we're going to go up by 2.3%. So that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that and calculate 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018, but you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312. And I'm going to round this to 42. I'm going to round it to the nearest penny. Okay, so that is Superbank. That's how much we'd get. Now, the Great Bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%. And then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022. So times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I round it to the nearest penny. Okay, so it says, which account will give her the most money? Well, looking at that, it's going to be the Superbank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be Superbank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much, so I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could have just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now, multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do. So either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always, And 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So on your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89 and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to the nearest penny because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to 917 pounds. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Okay, so this is quite a complicated looking question, but the most important thing is we break it down. So it says a circle is drawn inside a square. Square has a height of 12 centimeters. So the first thing to know is it's a square. Therefore, the width is also going to be 12. And be careful to look out for that. Whenever you've got a square, they might only give you one of the dimensions. They won't always say it's a 12 by 12 square. Okay, so you've always got to assume that the other one, or you've always got to know that the other side is going to be the same. Okay, it says work out the shaded area. So the thing we notice is it's like a quarter of the square, but with the circle removed. Okay, so the first thing to do is work out the area of the square. So area of square. Okay, so the area of the square is going to be quite easy. It's going to be 12 times 12, which is 144 centimeters squared. Okay, next thing to work out is the area of the circle. Okay, now this you need to remember the formula, which is pi r squared. Okay, and that you do need to know because you're not given that in the exam. So it's going to be pi times, and now what is the radius of that circle? So the radius is halfway across the circle. Now the circle has the same height as the square, or the same diameter as the square's height. Okay, so the radius is half of that, so it's going to be 6. So it's going to be pi 6 squared. 6 squared is 36, and we write that as 36 pi. Okay. Now, it's an uncalculated question, or it could be in the non-calculator, it could be in either, okay, but it does ask us to give our answer in terms of pi, so we're not going to go any further than that, we'll leave it as 36 pi. Okay, so we need to work out the area of all of the outside, okay, so we're going to do all of the outside, okay, including this shaded bit, okay, so area outside circle. So I'm trying to show the examiner that I'm working out the area that I've shaded in red. So the area of that is the area of the square, which is 144, take away the area of the circle, which is 36 pi. Okay. Now to work out the shaded area, which is what the question asked for, Now, looking at that, we've got 4 parts. We've got this part, this part, this part, and this part. And all 4 of them are equal, and we only want one of them. Okay? So, to work out the shaded area, we get our answer from before, and we divide it by 4. So, we're going to divide the 144 by 4. And it's dead easy to divide by 4, because you halve it, then halve it again. So, half of 144, well, half of 140 is 70. Half of 4 is 2, so that's going to be 72. Then half of 70, half of 72 is going to be half of 70, which is 35. Half of 2, which is 1, so it's going to be, what did I say, 36. So it's 35 plus 1, which is 36. Okay, next we're going to halve the 36 pi. So we only need to halve the number before the pi, and that would have the same effect. So we're going to halve 36, or we're going to divide it by 4, but we're going to halve it first, which is 18, then halve it again, which is 9. So we need to divide each one by 4. So I've divided that by 4 to get to 36, and I've divided that by 4 to get to 9. So my answer is 36 take away 9 pi. Okay, so we have a quite tricky looking question. Now, this is the same question as what I'm about to draw. So if I draw the big triangle and I draw the small triangle separately, and if I just say that they are similar, which means one is a direct enlargement of the other, it becomes a much easier question. Now, whenever you see this question here, always just draw it as 2 separate triangles and try and fill in the lengths. So the small triangle has a height of 2, a right angle here, and a width of, or a base of x. And the big one has a height of 6. Now the width is going to be x plus 4. Okay, and that's going to be key in answering this question. Okay, so because they're an enlargement, we've got to work out the scale factor. So what do I times the 2 by to get to the 6? So the scale factor is going to be 6 divided by 2, always bigger divided by smaller, which is 3. Okay, so I times anything on the smaller triangle by 3 to get the length on the bigger triangle. So we've got x here, and what do I times it by to get to the new length? Well, I times it by 3. So I know that 3x is the same as x plus 4. So I've got myself a little equation here to solve. So first thing, if you've got x on both sides, you always take away the smaller amount of x. So I'm going to take away x from both sides. So to get 2x equals 4. Let's extend the lines a little bit. And I'm going to divide by 2 both sides to get x on its own. So x equals 2. Now let's see if that works. So if x was 2, this length here would be 2, and this length here would be 6. And we know that 2 times 3 is 6. So we know it's the right answer. So the length of x is 2. And there's loads of different other ways you could do this one. You could do it through trial and improvement, and there are a few other techniques, but I think the method I've shown you here will work with any of this type of question. This isn't the simplest question. In fact, it's probably the most complex question that you can get on this kind of similarity. The important thing to realize is if you ever see this kind of question with a triangle in another one, you should be thinking, are they similar? And anything that looks like this will involve this triangle being similar, which means that there is a scale factor to this triangle. Okay, so in this question we've got a Venn diagram, and we're supposed to fill it with all the numbers from the information shown at the top. So we need to go through the notation. Notation's pretty basic when you know what you're doing. This little E symbol here just means everything. That means those are all the numbers we're going to use in this question. Now it says that the A is all the multiples of 4. So we know all the multiples of 4 are going to go into A, but we can't fill them in yet because we don't know whether they're just in A or in that kind of overlap. So this is what the next piece of information is going to be. This little symbol here means and. Now if you think about it, with a little line across, it would say and. Okay, that means that those numbers are in both A and B. So actually we can fill those out now. So 16 and 40, they're going to be in A and B. Now we can cross them off from the list at the top, and actually we can have a look and see which other multiples of 40 are in that list. So 80 is a multiple of 40, so that's going to go in A, and 28 is a multiple of 40, so that's going to go in A as well. I think that's it. Okay, now we can't fill in the rest of them into B because they could be outside the Venn diagram, so we've got to just stop a little bit and have a think. So this last one says A union B. Now the union is just a posh way of saying or. It can be in A, it can be in B, it can be in both. So it's either in A or in B or in both. Okay, it's just in the Venn diagram. So let's have a look and see which numbers we haven't used yet in that list. So we've used the 16, we've used the 28, we've used the 80, we've used the 40. So we're left with the 1 and the 9. So let's cross that off from my list. So that leaves 47 and 3. So where do those go? Well, they go within the E box. Okay, and E stands for everything. So this is kind of our everything box. Nothing exists outside of here, for the purpose of the question anyway. And we just put them here. So it's not in the Venn diagram section, but it's still in the box. Now the last thing to do is just go through and check that you've got the same amount of numbers in your Venn diagram than you should do. Check all the multiples of 4 are in A. So let's have a look. 80, 16, 28 and 40, they're all multiples of 4. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X. And I realise that it needs to be trigonometry, because this is a rectangle, that's a right angle. So I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse. So we're going to use sine. So SOH. So it's going to be sine 68 equals 27 over x. And I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.8 29.1204. And I just do a few more decimal places than usual because it's not an answer and you should never round your working out. If it's asking for 1 decimal place, I think 4 decimal places should be enough. But I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90 because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y, and I've got, so what have I got? I've got the adjacent here, so this is now the adjacent, and I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos, so it's CAH. So cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah. And it says it wants the answer to 1 decimal place, so it's going to be 31.4. Now, if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine. You'll get the same answer. Okay, I hope you enjoyed that video. Like I said, you can do the questions online. On the online paper, all the numbers constantly change, so you're not just remembering answers, you're remembering techniques. We also have the new Revisionator online, which is a really, really good tool to just do random questions. We also have mock exams, demon questions for the harder questions on the GCSE course, mini mocks, and there's all sorts of other things on the website. We also have the remaining topics on our website, which you can just go through all the exam questions we have for the remaining topics. If you like this video, please click like, and if you want to see more from us, click subscribe. Thank you very much.